So this is chapter 15. It's about descriptive statistics. So chapter 14 was about collecting the data. Was part of what chapter 14 was about. But chapter 15 is like, okay, now that we have collected the data, now what do we do with all these numbers? So for example, we're going to see an example in a second. We're going to collect all of these test scores and that all of these numbers collected from these people, those are what's called the data set. And then each individual test score would be called a data point. So in 15.1 here, we're going to go over visual ways to describe data, graphs and charts. And then in 15.2, we're going to talk about calculations that we can do to find to help us summarize the data. And then in 15.3, we're going to talk about things that help us measure how spread out the data is. So this is 15.1. And you might be asking, Wash, why do we have to do graphs? Well, when someone does a research study and they get a lot of, maybe they had 1,500 people that were sampled. Now they have 1,500 pieces of data, that they need to do something with that. What are they going to do with that? If somebody asks, what are the results of your study? Are they going to just list all of those 1,500 pieces of data? Is that how they're going to present the results? Probably not, right? And what's great is one picture is worth 1,000 words. And so we can use a picture. We can put all this information into a picture. They can quickly kind of summarize what the data say and help us draw conclusions about the data. So the first way that we are going to put things is a bar graph. It's called a frequency bar graph. That is literally, we're just going to be counting the number of people that responded in a certain way in the survey, and we're going to make a bar that's the height. The height of that bar is the number of people who responded that way. So I think you probably did it in like third grade or second grade, like where you had to go around the whole class, ask, how many people are having turkey for Thanksgiving dinner, how many people are having mashed potatoes, or whatever, whatever you want. And then you would graph, you'd count the number of people that are eating turkey on Thanksgiving, and you would make a height. You'd make a bar that was that height, so you're just counting the number of people that have a certain characteristic, and you make a bar at that height. That's a frequency bar graph. A relative frequency bar graph, the height is no longer the number of people with that characteristic, but the height of the bar is the percent of the population with that characteristic. So sometimes it's written as a decimal, or sometimes it's written as percentages. I believe in this textbook, they write it as percentages. Sometimes instead of going percentages, they write it in a decimal format. All right. And then a pictogram, a bar graph, is a bar graph that uses little pictures instead of like a single bar looking thing. It uses a little picture instead. And a histogram is a bar graph that uses same size intervals. And we'll see when there's lots and lots of possible responses to a certain research question, they will use a histogram with intervals. So if you have a research question like, how many kids do you have? There's only so many responses. People are going to probably respond between 1 and 6, right? And so we can easily make a bar that is, that height is like, okay, we'll say how many people have one child, and then we can easily draw a bar that's above the number one, and then the height of that bar is the number of people that have one child, but if it's a different type of question, let's just say if we ask people, what is your height? Well, that number can vary quite a bit. And it's going to be harder for us just to be like, well, everybody that is 6 feet, 2 inches tall, we're going to make a graph. We're going to count everybody and make a bar above that height. But there's so many different heights that people could be that we're going to have a lot of bars. And sometimes there's just too many bars. And so they'll say, well, anybody between, 5 feet and 5.5 feet. That is it, that we're going to make a bar and we're going to include everybody. We're going to count everybody between 5.5 feet and 6 feet in that bar. So that's called the class, or it's called the interval. And on a histogram, there is no gaps, as we'll see that we see in a bar graph. A pie chart is a circle graph where categories take up the form of wedges in a pie, and each wedge represents the category percent of the whole population. So it's a pie charts are great if you're trying to compare what percent that one thing is of the population than another thing. So it's used when it's used with small when they have a small number of categories. And there's 2 types of variables here. And when they say variables, when I was learning this stuff, when they said the word variable, it scared me. I was like, what variable? But when they say variable here, they just mean research question. So like I said, am I asking how many kids do you have? That variable has very few different types of responses. And it also is a number response. So we call it a quantitative variable. If it's numerical, if the research question you're asking is a number response, then it's a quantitative type of variable. So an example is, how many children do you have? Because the response that people are going to answer is 0, 1, 2, 3, 4. It's a numerical number response, right? Okay, a qualitative variable is a research question, or it's what we're going to be collecting data on this topic, or the research question that you're asking people and you're collecting data on. This one is actually a word response, or a category response. So it's a non-number response. So if you asked, what nationality are you? If I wrote down all the nationalities from all the class, people don't respond with, I'm nationality 5. They don't give you a numerical response. They give you a word response. I'm Filipino or whatever, right? So that is an example of a categorical variable. And we emphasize this right now because we're going to see that we can't do calculations, of course, with categorical data. We can't find averages or do as there's a lot of things that we can do with numerical data, and we can't do all that with categorical data. So that's why they're making a difference here. All right. Then, okay, let's see this first example. Consider the following data, consider the following table of midterm exams scores of 75 students in a math class. So there must have been 75 students in the class, and they have recorded here all of their exam scores. A student first wonders how they did. Secondly, they may wonder how the class did as a whole. And that's why we do statistics like this, because for whatever reason, we always want to ask ourselves, well, how did we do on this test? But then the second question is, yeah, but how did I do compared to the other kids? So in order to answer that question, how did I do compared to other people? What we're going to draw a graph. And you could reconcile where you are in the graph compared to other people. So it's kind of really small here, but here is the score. See, this is the score column. So the first person with student ID 1257 has a score on this quiz of 12. I'm assuming it's probably like out of 12. I don't see, oh, there's 14. So there's a score of 14. So it may be like a 15-point quiz. They don't tell me how many points in total the quiz was, but I guess that's not important. But the second person, they had a student ID of 1297 and a score on the quiz of 16. So apparently it's more than 15 problems on this quiz. And the third person, they have a student ID of 1348. This is not real students, but then their quiz score was 11. So all of these numbers, their scores, their test scores, that's called the data set. And then a lot of times your textbook will assign the capital N, the number in the data set is capital N, which is 75. Don't confuse that with the capital N. And when you get to statistics class, usually the capital N is referred to the number of people in a total population of interest. So don't confuse that with what you may see in a statistics class later on. And guys, just so you know, you're going to see little differences between textbooks, between, just between textbooks. So it's important. Sometimes you can't always just go online and be like, oh, well, what's this variable mean? Or what's that mean? Because it differs textbook to textbook. So you kind of have to be careful with some of these notations and making sure that you get it right. Okay. All right. So what are we going to do with all this? Like if somebody says, okay, well, what is my score and how did the rest of the class do? I mean, what would I respond to them? Am I just going to list out all the different scores? Just say, well, that would take me 15 minutes, just not 15 minutes, but it'd take me like 5 minutes, whatever, to just list off the different scores. And I don't know if it would show you that much information. You'd be like, oh, okay, like that didn't tell me anything, like. So the first thing that we do is we try to take the data and organize it into a frequency table. So what it is everybody that got a score of 1. I count how many people got a score of 1, and I put the frequency. The frequency means how many people had that score, right? And so there was one person, according to this frequency table, there was one person who had a score of 1 on this quiz. There was And then the next score is 6. You see this 6. And there was one person who got a score of 6. There was, and we can keep going down, there was 9 people who got a score of 12. And there was one person who got a score of 16, one person who got a score of 24. Wow, so I guess that quiz did have more than 15 or 16 questions. Okay, so you can see, looking here, all we did was simply tally the number of people that had a particular score and put it in this table. It might be easier for you if you had to fill out this entire table. The easiest way to do it is, go down this list and say like 12, okay, let me draw a line, one tally under 12. Okay, 16, let me draw a tally under 16. Okay, the third person, 11, let me draw a tally under 11. And normally you would do it that way. And then when you list out all the different scores and you tallied them all up, then you would get these numbers, 13, 9, as you count the tallies. So we can do that right now for the number of people that have 7. So you see this 7, it says fill in the missing numbers. So they want us to go to the chart and find out how many people had a score of 7. So I look, and I just look at the scores and I'm looking for the number 7. Well, there's one right here. So that's 1. Two. So I just saw 2 with that had 7. So I'm just going to put a 2 down here. And we might want to double check it and just do it one more time just to make sure that there's actually 2 there. But I see 1 7 is here and 1 7 is here. And let me just double check that there's no other 7s. I don't see any other 7s. So I think there are 2 7s. All right, then they ask us, the 14 is missing. See how this is missing right here? So they want us to find the frequency of 14. So they just needed us to count how many scores were 14. And I'm going to circle them so I can easily add them later. So I'm looking for the number 14. So okay, so I see 1, 2, 3, 4, 5. There are 5 people with a score of 14. So under frequency, I put 14. I'm sorry, I put 5 for the frequency for 14. And that's how we fill out that table. Okay, that's easy enough. This is what we call right here on the bottom here is a frequency table. And that's the first thing that we do. We're trying to organize the data. Next, we take a frequency table and we make a graph. And the numbers along the bottom of the graph, the horizontal axis, are going to have these scores, and then the height. And then this would have a rectangle above the score of 1, and it would be height 1. Be a rectangle above the number 6 would be a rectangle of height 1 as well. Above the number 7 would be a rectangle of height 2, and so on. So the frequency is the height of the rectangle, and at the bottom of the rectangle, it shows the score that they're talking about. So that's how we would make a bar graph. And so I believe, oh yeah, that's what they've done here. For questions on this page, identify the graph type, frequency bar, relative frequency bar, histogram, pictogram, or pi. Identify the variables as qualitative or quantitative. Questions 1 through 3 represent the data of the midterm exam of the previous, represent the data on the midterm exam for the previous table of 75 math students. So just like I was saying a minute ago, this is what a bar graph looks like. So they took this frequency table and they said, they wrote, like I said, the scores along the bottom of the axis. So there's the scores. So above 1, they made a rectangle of size 1. Above 6, they made a rectangle of height 6, not size 1, but height. I'm sorry, gosh. Let me restate that. Above the score of 1, they made a rectangle with a height of 1. Above the score of 6, they made a rectangle of height 1 as well. And that's because on the previous page, score of 1 had a frequency of 1, and score of 6 had a frequency of 1 as well. Okay. Let me, I'll do this. Okay, so like I was mentioning here, that see this score, they copied the scores, the 1, 6, 7, all of those, and they put them on the horizontal axis across the bottom of the graph, right? So see the 1 is there, the 6 is here, the 7 is there, and they added some other numbers, but notice how they're all no rectangles because there was no frequency. There was nobody who scored 2 on this exam. So that's why there's no rectangle above 2 or 3 or 4 or 5 or 6, and so on. But there is a rectangle above 6 because there was one person who had a score of 6, and that's why the height of this rectangle, if we trace the height of that rectangle back to this vertical axis, it's 1. So less than 2, because 2 is the black line right here. So if there would have been 2 people, it would have been as tall as the black line, but there was only one person, so you see it's not as tall as the black line. So there's something really important about these bar graphs is you want to always read the name, the label they have on the x-axis. The x-axis is your horizontal left and right axis across the bottom. That's the score. So that's why I said these are the numbers along the bottom. Then they say the percent of students receiving the score. Great. I actually wanted to just do, oops, I was actually trying to do the other problem. So let me switch over to the other problem really quickly. And this is why it's important that you look at both the x and y axis, which means your horizontal axis, the way it is labeled, then with the white words, and with the vertical axis, which I did not do. So let me switch this real quick. Okay, now this one is the correct graph that we want to look at. So notice how the score are these numbers here. And then those are where the numbers are going to be listed along the bottom here. And then the heights, the vertical axis is this frequency. So that's your vertical axis here. So that's why we see that above a score of 1, you're going to see a rectangle of height 1. And we could read the height of this rectangle by tracing it back to see how tall it is on the y-axis. So that's why it's between 0 and 2. Like there's a black label labeled here as 0 and 2. What's right between 0 and 2? 1. Okay, and then so that's why we see 6. Above this 6 labeled on the x-axis, we see a rectangle also, the height of 1. And that's because there's one person who got a score of 6. Okay, and so on. And we can see like that if we look at 9, a score of 9. So here's a score of 9, that the height of the rectangle above that should be 10. So we look at the height of this rectangle above 9, and it for sure, we can measure the height by looking at the y-axis here. And it is 10, a height of 10, and so on. So this is what a a bar graph looks like. It is just the frequency table, but with that, instead of putting a number for the frequency, like you see here, see for each score, instead they put a rectangle, and the height of the rectangle is the frequency. So it just shows us more visually the information here. And what really it shows us is how frequent each score is. And quickly, looking at this graph, we can see what is the most popular score. What is the score that was the most students scored in which way? So we can see that the highest rectangle here is 16, right? So, or I'm sorry, the frequency was 16. That means 16 people scored, and the score was 10. So there were 16 people who scored a 10 on this quiz. That was the most frequent. And we'll talk about that later. It has a special name that goes to it. And then you can see the second most common score on the test was, and if we would see the score is on the x-axis, so we have to go down to find the score. That's 11. And if we go over, we can see the number of people who scored that way, which is 13. So, and when we're looking at this, it really shows us a good picture. So if I scored, let's say I scored a 24 over here, I can quickly notice that I'm the only one who scored that high. And most of the kids in the class scored quite a bit lower than me, right? And we can see most of the kids in the class kind of scored in this region. So between 6 points all the way up to 16 points. So we can kind of see several different things really quickly from graphing a graph like this, okay? Now, a very similar graph, and all they did instead was, instead of doing the frequency, instead of this vertical axis being the frequency, it's the relative frequency. And let me show you what a relative frequency is. Okay, so the relative frequency is the frequency itself divided by the total number of people the total number of people. So how many people scored 1 on the test compared to the number of people who took the test? So that there was 1 person out of 75 people who took the test who scored 1. So that if we divide 1 divided by 75, we get this 0.013, which we could leave as a decimal, or we could write as a percent by moving the decimal twice to the right. And that would leave me with 1.3%. Okay, and the same thing with this second column here, how many people scored a 6? Well, only 1 person, so 1 out of 75 people who took the test. So if I move the decimal twice, that's 1.3%. Okay, then how many people what percent of the people scored a 7 on the test? Well, 2 out of 75. So I turn that into a decimal by doing 2 divided by 75. And that is 0.026. I move the decimal twice, and that's 2.6%. Okay, and I can continue doing this. For people who scored 8, that was 6 people out of a total of 75 people. So Can erase that. I already put 2.6 for that one, so I was decimal there. And then 6 divided by 75 is 0.08. So that is, move the decimal twice, that's 8% of the population. The people who took this test got an 8 on the score, and so on. So this is how you do relative frequency. It's the frequency over the total number of people who took the test. And then you divide the numerator, top number is 10 divided by 75. And then you get this 0.133, move the decimal twice, and that's 13.3%. Okay, and then the next step is if I want to do a relative frequency graph, I am going to figure out the relative frequency for the rest of these in percent form. So let me just pause the video as I do that. Okay, so like I said, we have the score. We now have the relative frequency written as a percent. And so instead of doing, the score is going to be the same. See, I look at the x-axis, it says score. So all these numbers are going to show up over here, right? And then this number, instead of being the frequency, the heights of the rectangles are no longer going to be the frequency. They're going to be the relative frequency. Strangely enough, that it's still the same number, like 1 in the number, if you have a frequency of 1, it's also percentages of 1. So that's why that happened to work. So that's why the height, so notice what the labeling on this y-axis says, the percent of students receiving this score. So that's why we did the number from the total, so over the total to get that. So over the score of 1, we make a rectangle of height 1%. And then over a rectangle of 6, we make the relative frequency is 1%. So that's why we have a rectangle of the height 1%. And then like so on, that's why when you look at, let's just focus on like 12, a score of 12 has a relative frequency of 12. That's randomly the same, okay? But anyway, so if I go to score 12, and then the height of that rectangle is also 12, because 12% of the people got a score of 12, and so on. So the height of every rectangle here is the percent of the total people who took the test who had that particular score. Okay, that's a relative frequency graph. So it's really important when you're learning about these graphs to read your both your horizontal axis and your vertical axis to really understand what the graph is talking about. And usually also the graph will have a total on or like a title on the top, and that's really important to understand the graph as well. But anyways, let's see our last. So we saw so far, you saw a relative frequency bar graph. I'm sorry, you saw a frequency bar graph. That's what this one is. And we're going to call it a frequency bar graph. Then the second graph over here, this is called a relative frequency, and it's because this horizontal axis is a percent. And then down here, this one is very similar to a frequency bar graph, because if you look at the bottom, it's the score, and the side here is the frequency. But the only difference between this picture, where it's a frequency bar graph, and this one is that instead of having rectangles, they put little pictures. So because there was 12 people who scored, we could look back at the frequency table, there was 12 people who scored, no, okay, there were 16 people. 16 people scored a value of 10. So let's just count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they just like drew 16 little pictures on top of that score 10 to visual, so we could visually see how many people scored each of these scores. And they call this a pictorial pictogram. Pictogram. And like I said, it's very similar to the frequency bar graph, but you use pictures instead of bars. So people like this method because it's kind of easy to do a tally at the same time as drawing your bar graph, like your pictogram. So let's say that I was continuing, if like there was 10 more people that scored on the test, I could pick up the next test and be like, okay, this person scored 8. And then I would draw a little like picture above 8. And then this next person scored 24. So I'm going to draw another picture over here. And then another person scored 16. So like you can easily add to this graph and you can easily kind of do a tally at the same time as you're doing your graph. So that's what's kind of nice about this pictogram. All right. The next type of graph that we're going to go over is a pie chart. So this is what a pie chart looks like. And what it says here is there's a total of 24 hours in a day, and they're saying, and it shows you this is the way, I guess they looked at the average student and how much time they spent sleeping, how much time they spent doing leisure or sports, how much time they spent working, and how much time they spent on education, eating, grooming, travel, and other. So see, this is called a pie wedge. And it shows, and this is called a central angle. The larger this central angle is, like it was out here, then of course the more percentage of your time is being spent on that particular item. So we can kind of see that the smallest little piece of pie here, so it looks like it's this one, grooming. We can see that this person spends the least amount of their day grooming, and they spend the most amount of their day sleeping. And that's what's kind of really nice about a pie chart like this, because you can easily kind of compare and visually see, how much more time you're spending in one area than the other. And you can easily see which area you're spending most of your time in. And for me, like it would be very educational to me. I'd be like, wow, I didn't know I spent that much time eating, or, or that much time on sports. Well, to me, if I saw this picture just myself, like I would be like, how can like I'm spending more time on leisure time and sports than I am on education. And that would be just a shocker to me, because it looks like this little orange wedge is a little smaller than the blue edge. So like that would be like, oh my gosh, where am I spending my time? Like so what's so nice about this, like I said, we can easily compare categories and see which, in comparison to the amount of time I'm spending on leisure, what does that compare to the amount of time that I'm spending on education? And you compare categories really easily. And I said categories here because this is actually a categorical data. When you ask somebody, how much time did you spend, traveling or working, or these are word responses. So okay, so it says, but The graph to the right shows how college students spend their time. What type of graph is this? This is a pie graph. And the type of variable is a categorical or quantitative variable. So qualitative. So quantitative means quantity, which how much you have. So qualitative is usually like how good is something. So this is which would be a category. Qualitative or categorical. Because the things that they're kind of comparing here are travel, grooming, eating, education, and so on. Categorical. What percent, so then they ask us, what percent of time do students spend working? So they give us this 4.1 hours of work. Oh, I'm sorry. I'm on the wrong one. Working, spend working. So I go to the wedge that says working, and it says 2.4 hours. So to figure out what percent that they really mean here is what percent of their total day is spent working. So I have to take 2.4 hours out of the total day, which is 24. And then I just divide. So 2.4 divided by 24. Okay, so I did 2.4 divided by 24, and that gave me 0.1. And then now if you take that decimal and you move it twice to the right, you can turn it to a percent. So it becomes, and you ignore the decimal, 10%. Then they ask, what percent of time do students spend on education? So here is the education. So I'm gonna do the same thing again. I'm gonna do 3.3 over 24. So that means I'm going to take 3.3 and divide by 24 in my calculator. That means that 3.3 goes first, hit divide, and then 24. I get a decimal. And that is 0.1375. And then if I'm going to move the decimal twice to the right, and that gives me 13.75%. So 13.75% of their time is spent on education. And there we go. That's your pie graph. The next graph, so they want us to look at this graph and answer some of the questions. They say, refer to the graph at the right. Now this one, notice how instead of putting a single number below like one of the rectangles, right? They are putting a range of numbers under the rectangles. So it's showing me that, and they do this when there's a lot of different data that vary a lot. If they ask some type of question and there's, like a lot of different answers, and so it looks like people said, how much money do students earn? And what are their salaries? So, I mean, one person is going to say 41,000, another person's going to say 105,000, and everywhere in between is going to be a different response. If I made a rectangle for every single different response I got, that would be just too many things on this x-axis. I can't make 41 for 40,000, one for 41,000. I mean, we would go from 40 all the way to 105 or whatever the top salary is, right? And that would just be a really long graph with a lot of different rectangles, and it just wouldn't be very valuable for us too. Like it. So instead, what they've done here is they have made a class interval, and they said, okay, well, anybody that makes between 40,000 and 50,000 on 45,000, sorry. That's what this means. Between, or actually that little plus sign, we'll talk about it a little bit, but the plus sign means more than 40,000 up to 45,000. And this one means more than 45,000 up to 50,000. And this means more than 50,000 up to 55,000. And so on. So we're going to count the number of people, and it looks like that they had 3,258 people that they they sampled. They asked what is your salary, and it looks like, and these are percentages of the graduate students. So it looks like about like 6% or 7% of people responded that they make between 40,000 and 45,000 a year. I'm assuming they're saying year. Okay, and then there was, it looks like maybe 14,000, I'm sorry, 14% of people made between 45 and 50,000. And then it looks like 33% are between 50 and 55, and so on. Okay. So that makes it a little bit easier so that our horizontal axis isn't so extremely long. We just like grouped, and these are called class intervals. So they just like grouped a bunch of numbers together, and they said we're going to count all of those as like one. And those numbers are really similar, so it's not like that. We're still going to get a good picture of the data. Okay, so they say what type of graph is this? I'm noticing that I'm noticing that these touch each other. The rectangles, unlike the pictures over here, there's like space between each rectangle. These ones touch each other, so this is a histogram. How many students earn between 40 and 45,000? So that's this one right here. And it looks to me, gosh, it's kind of hard to, I'm just gonna say, and this is where you just estimate to the best of your ability. I'm gonna say 7%. 7% of 3,258. So how do I find 7%? You have to remember that the O and the of means a multiplication dot. So you're gonna turn the percent to a decimal by moving the decimal twice to the left. So 0.07, 7% becomes 0.07. And then you're going to multiply it times by 3,258. And you're going to get, so 0.07 times by 3,258 equals 228. .06. Okay, then how many graduates earn between, oh, these are graduates. Okay, just noticing, okay. How many graduates earn between $65,000 and $70,000? So between 65 and 70, this looks like, okay, this is going to be easier because it's right on the black line. So okay, that's 5. So I need to find 5% of the total number of graduates, which they tell us that the large N, which is the total number of people in this, they took information from in this study. So it's 3,258. So like I said, I'm going to turn this to a decimal. So it's 0.05. And the O means multiply in the of 3258. And then I'm going to get an answer. And I just wanted to make sure that you know that like these answers need to be whole number responses. So we should round these answers. So I'm going to do 0.05 times 3258. And I get 162.9. And I think it's fine if we just round regularly here. So I'm going to do it round to 163. So there's about 163 of those graduates who make between $65,000 and $70,000. And I'm going to round this just regularly, so down to 228 that make between between 40 and 45,000. Then they say, what is the length of each class interval? Now, this is something else that differs depending on the textbook that you're working in. But this textbook, they take the upper limit, subtract the smaller limit. So it's 45 minus 40, and that's the class interval is 5. And they try for the most part to make that consistent with every single class being a width of 5. So that's the length of the class interval is 5. Describe the endpoint convention. A value that falls exactly on the boundary between the two class intervals belongs to which class? So they're talking about like, what about like 45,000? Somebody who makes exactly 45,000, are they going to be counted in this group or they be counted in that group, right? And the answer is they're going to be counted in the lower group, this group over here. There, because this includes 45,000, and that's why it says 45 plus, because it means more than. You have to be more than 45,000 to fit in this bigger group. So they're going to be included in the one on the left. Suppose a person earns $50,100. So they're going to be in, that falls between 50,000, it's bigger than 50,000 and less than 55,000. So they're in this group. They would be counted in that group. Okay, so that's in like the third class interval. At the 1, 2, I'm just saying that's the third over. All right, and then if a person earns 50,000, to which class do they belong? So this is when they're right on the borderline, right? So 50,000 is right here. So they're actually going to belong to this 45, the class that includes 45 and 50,000. So and my pen doesn't really want to work right at this moment, but all right, but anyways, the person, they would belong, if a person earns 50,000, they would belong to that second class over, which is from 45 to 50. Okay, so they're just confirming to you that the endpoints of the categories. Okay, they say we can look at these two graphs, and there is like an art form to making these graphs. And we can look at these two graphs and kind of see the differences, that they're still showing the same exact data, but so you see that's 2011, 2012, 2013, 2014. So that's the same across the bottom. These same numbers are across the bottom, right? And we kind of see that like the highest number is 80 and the lowest number here is 50. The lowest number here is 0. So they kind of stretched. It looks like in this graph, they stretched out this vertical axis. Okay, and this one is they kind of, and it's fine. They just like cut off the vertical axis and made it start at 50. But notice how in this graph, it looks like it's really increasing. And in this graph, it kind of looks like it's all just flat. So the moral of the story here is that there's kind of an art to drawing these graphs. There's not like a right way sometimes. And people can be misleading if they want to. They can really make it look like, wow, look, as the years went on, the dollars increased. Because it looks, that's what it's exaggerated in this picture on the left. While the picture on the right, it looks more like the it looks like it's more stable, like it does increase as we go from left to right, but not by much, it appears, so it's just showing you the different types of ways that the graphs could be drawn and that could affect your perception of it. Or anyways. All right. This bar graph, okay, so we're almost done, but the bar graph describes the scores of a group of students on a 10-point math quiz. How many students took this quiz? So this is let's read this. It scores along the bottom, the x-axis, and along the y-axis is the frequency number of students, or the vertical axis. So if we just add up all the heights of the rectangles, we're going to get the number of students who took this quiz, because we know that 3 of them scored a 3, and 4, and let's go ahead and write this out. We know that there's 3 kids that scored 3 on this test. There is 5 kids that scored 4. So 3 plus 5. There's 2 kids that scored 5. There's 7 kids that scored 6. There's 10 kids that scored 7. There's 5 kids that scored 8. There's 3 kids that scored 9, and 5 kids that scored 10. So if we add these all up, that'll be the number of kids, and we will get our answer there. Okay, so it looks like there's 40 people. When I add up all those numbers, I got 40. So there's 40 people who took this quiz. Then they ask what percentage of the students scored 1 point. But look at the scores along the bottom. I don't even see 1 point at all. So I don't think that anybody scored 1 point. So I'll say 0%. Okay, if a grade of 7 or more was needed to pass, what percentage of students are passing? So we can go back to here that I said how many people are 7 is 7 or more. So 7 is the smallest number. So that was 10. So like that was between here and here, that was all the people that scored 7 or higher. So if we add those all up, that's 23. That's the number of people who scored 7 or higher divided by the total number of people, which was 40. So 23 divided by 40, that is 57, or 0.575. If I move the decimal twice, that's 57.5% of the people would have passed that test or quiz. And there we go. That is, I believe that is our last example, and then we'll move on to 5.2. So thank you for listening. Have a great day. Bye.